Okay, streams. Let's talk about streams. This is the new Java 8 streams, and I'm going to show you how to use them. We have here already have some code. We have a Congress class which contains people. People is a list of person. A person is, so you might imagine, has a title, last name, first name, etc., birthday, party. These are politicians. So they have the party association, Republican or Democrat. And that's it, basically. My main Java already wrote reads the list of Congress people from the file and prints them out. If you run that, it should print them out in this line right here. So you see it printed them all out. These are in the order in which they were read from the file. So first thing we want to do is, you see I have all these functions we defined before. I have a sort by last name. So we did that last time using this comparator that we defined in person. So I can just, it's right there, the last person comparator, which is defined right here. But you can do this. First thing I want to show is that you can do this with less typing using the comparator comparing. So I can say comparator.comparing and pass it a function. That is the function I want to use for comparison. Basically, this function is going to be a map from the person in this case, because I'm going over people. People is a list of person. So, and then what is it that I want to compare? P dot get last name. So I want to compare on that, and this line is equivalent to this line. You see, it's a lot shorter. It does mean though that this is now within the Congress class. So depending on how you're going to organize your code, that might be okay or maybe not. So, but there you go. And you can see, so you can test that quickly. And it should work. It should just be just like before. Wait, I forgot to actually call it. So before, I have to call it that sort by last name and then print them out. And now you see they're sorted by last name. So still works. Now you see our IntelliJ is highlighting that. It tells me that this can be replaced with a method reference. So this is a nice thing. When you have a function, this is a function. This is the new syntax. If this is a function that takes an argument, it's a variable called p in this case, and returns p.getLastName. So it's a simple function. This is the argument, and this is what it returns. So you're just kind of writing inline code there. And that's the syntax. This less than or this dash greater than mean is what you use to separate the argument from the function. If you had multiple arguments, you would say, a comma b, and then use those in the function. Get last name, for example. Whoops. Okay, but we're not doing that. We're doing this, and if you see, IntelliJ is already telling me, like I said, this can be replaced with a method reference. What that means is that, when I have something simple like this, that is just a call to a method, in this case, get last name, I can just put that method in there, person.getLastName, like that. And I use this other syntax, colon. So if the function is just calling one method, I can just put the method in there. And you see, there's no p here. I'm just calling the method itself. And then if I run this again, I should do exactly the same thing. So those are equivalent. So let's see it runs. Now this collections.sort mutates, it changes, right? The list in this case, people. Yep. So that is a big difference from the way we're going to be doing things with the stream. So while this is more traditional, collections.sort changes the, in this case, the people or whatever the list in place. When you're using the stream, which we're going to be doing now, the streams make a copy of it. So if I say people.stream, once I make that stream, that's kind of like a copy of people. And so it's not gonna, the people are not gonna change. So here I'm gonna sort these guys using a stream. So this is kind of equivalent with this, but it won't be changing the people. So I'm gonna sort them. I'm gonna use, as I said, the comparator.comparing. It says here I'm gonna do print sorted by last name, then first name. So I'm gonna do last name first. Person dot colon get last name. So there. So at this point here, when I said people.stream, I create a stream of people. This is a lot like the file input streams you're probably used to in Java, right? Reading and writing from a file. Though you see they are not the same. Not the same thing, but they work the same way. And then I'm going to sort that stream. So sorted takes a comparator as an argument, right? So, and then comparator, the class has some static helper methods. So this is says I want to compare using this, the results of applying this to everybody. So I'm gonna get everybody's last name and then do the compare to on each one of those. So that generates this new stream. Of course, you know, I want to print them. It says here I want to print them out. Like I said, this is not going to change people at all. People are still going to stay in the same order, but after this is sorted, they are going to be sorted. So I can do a forEach. So forEach says, you know, for now that they're sorted, so now they are sorted, and they go into the forEach, and I can print them out. Right. So I'm going to remove this and this, and then I'm going to call print sorted by last name, not first name, which is right now only doing last name. And I'm going to run that, and hopefully, yeah, they're still sorted by last name. So that works. So now they're sorted. Now another nice thing about this comparator is you can then compare it. So you can do this by last name, then first name, using this then comparing person first name. There. So you can chain this. This is a comparator. When you do this comparator comparing, it returns another comparator. And then you chain it up with another one. So you can compare first on the last name, then on the first name, like so, pretty easily. So that's very nice. I'm going to run that and show you. So now you see they are still ordered by last name first, but you see Lee and Ryan. No, well, that doesn't work. So I gotta find one where they're all the same. Smith. It's a good one. So you see a bunch of Smiths here, but their first names are alphabetical. Adam, Adrian, Christopher, Jason, and Lamar are all in alphabetical order. So that's how you do that. So that's the comparator. Another thing we might want to do is get the number of female Congress people. How do we do that? Again, people.stream, and then we're going to use the filter. So the filter, once you get the filter, takes a function that returns a Boolean. So if the Boolean is true, we keep that item. If it's false, we throw it away. So I'm going to filter. I'm only going to keep, so I'm going to say for each person P, I only want if P dot get gender equals female, gender.female. So this so now the stream contains only female. Only female. Right, now I have to count it. How do I do that? Count. So there's a nice little count method that will count how many things are in the stream. And yeah, I just need to return that. That's it. So this is how I count the number of females. I am going to comment that out. Say num female. Run that. And compile, run, and 108, which I think is correct. There's like 450 total. So that works. So filter is also very useful when you have to. You can, as you see, I passed this function here, but of course this can be anything, right? You can filter, you know, by party, by whatever. So you can write your own code in here. As long as it returns a Boolean, you're good. Okay. Fun one. Get the shortest name. So let's say we want to go through everything and find who has the shortest name. So I start with my stream as always. So now the name, because the person is the first thing is persons, you know, as the names are separated between first name and last name. So I want the shortest name that is, you know, the first and last name. So the first thing I do is the map. So first I have to do a map function to change from a person to a string, and not only that, but from a person P. So for each person P, what I want is their first name and then a space, why not? And then the last name. Yeah, we don't need the space because we're calculating the length, but whatever. So what this map function is going to do is going to apply this function to every person, and whatever it returns, that's the new stream. So what this means is that now it is a stream of strings, right? Because we mapped from person to a string, which is fine. So we have a stream of strings, and we want to find the maximum, or no, the minimum. We want to find the minimum in that string, but the minimum length, right? So not minimum in terms of alphabetical ordering, but so we have to pass the minimum. We pass it a comparator, which tells us how to calculate the minimum. In this case, we want length, right? So we put in a raw comparator here. We say A, B, and so A and B are the two things we're comparing, and A dot compare to B. Well, not A dot. A dot. We want that will compare alphabetical order. We want integer. Well, integer, please. Integer dot compare A dot length, B dot length. So that's one way of doing it. And we could create a new comparator right in there, and it takes the two strings. A and B are strings, right? I said from before, and I don't really want to compare the strings themselves. I want to compare the length, so I have to do this business here, compared to. So that worked. That would work. But a better way probably is to use the comparator comparing, and I'm comparing these two strings on length. So I'm going to say string : length, and so that's probably a bit, yeah, it's a bit shorter. Hopefully, maybe a little bit easier to understand. I'm not sure, but it seems nicer. And so that's going to return the minimum one, And the last thing I gotta do is get, right? Because remember these things, this min here is going to return an optional, which, you know, in order to get the value from an optional, you have to do the get. So that's the shortest name. So I know we're all dying to know. Shortest name is what did I call it? Shortest name. Run that. And the shortest name is Tetpo. Seems reasonable. Is that your congressman? So shortest name. Other party. So maybe you noticed when we printed out, it seems like everybody was either a Republican or a Democrat. Are there anybody who is not? Let's find out. We can do this. We're just gonna print out everybody who is from some other party. That is not Republican or Democrat. So yeah, we're gonna just use filter in this case. Person P. We want all the P who P dot get party. Nope. Get party is not equals to Republican. Not equal. Not. And it's not equal to Democrat. And then for each one of those, I am going to print them out. Again, you notice it's telling me, hey, you don't need this. This can be replaced with the call. So, and it says so up here too. Now let's do that just for this one. So, system.out println, like that. So print other party. Run that. And here they are. There's 3 independents. So next. Finally, print by party. So another thing you can do is use these the collect method, which is what we're going to do now. So you can take a stream and collect. This is similar to like order by, group by, sorry, in SQL, if you've ever done that. So we're gonna collect them, basically group them together using, in this case, party. So we say dot collect, and then I have to give it a collectors dot grouping by, and then tell it what I want it to group by. In this case, person get party. So I want to group them by the party. Now, what this is going to return is something interesting. It's going to be a map from, in this case, I'm collecting on get party, which is a string. So it's a map from string to a list of person. We call this collected or grouped. I like grouped better. Grouped. So this is what that's going to return. So when you do a collect, is going to basically, the key is going to be the thing that you're grouping by. So the key is going to be, in this case, either Republican, Democrat, or independent, as we saw. And then the values for that key is going to be for Republican. Then you're going to have to list, you'll have a list of all the Republican people. For the Democrat, you have a list of all Democrat people, and so forth. So I can print them out now by the party using, I can just, I'll say list person, Republicans equals group dot get Republican, And that should give me all the Republicans, Democrats, Independents. Okay, and then I can print them out using the standard ways. So I'm gonna go with the independence because there's a few words. Independence dot stream dot forEach system dot out print. So I'm just gonna print those independents. So I'm gonna comment that out so it doesn't print those out, and print by party. Run that, and there they are. The three independents again. This will work if I can just, instead of printing independent, I can print the Democrats, for example. Run that, and there they are, all the Democrats. You see, Democrat, over here. Okay. So, some good examples.